Well, I think this is working. I have not done this in quite some time, so someone please let me know if you cannot hear or see me or any of those things. Thank you for joining me today. My name is Eddie Zaneski, and I am going to go through a talk that I gave last week at a conference called That Conference. That was not recorded, unfortunately. So this is my method of recording it, so it is on the internet and I can point people at it. Cool. Very cool. Awesome. Thank you for letting me know that you can hear and see me. So without further ado, I'm just going to jump in. And hopefully this slide presentation works. So the point of this talk, and actually I should just start with the CFP. So this was the talk that I gave last week. Kubernetes helps developers run container workloads at scale, but the real innovation lies with its extensible and declarative resource model. Kubernetes controllers transition resources in response to events and state changes, much like ReactJS, and its state-driven rendering brought about a new paradigm to front-end development. In this session, you'll learn about the Kubernetes resource model and how its controller pattern can be extended to manage resources from team-specific workload definitions to Domino's Pizza's orders. You'll learn the basics of client Go, the Kubernetes SDK for Go, and how to use its primitives to build a controller from scratch. Cool, very cool. So jumping in about me real quick, I work for a pretty cool company called ChainGuard. Thank you for sending me to that conference last week to give this talk. I also am a maintainer for the Kubernetes project. I spend most of my time working on kube control and our build and test infrastructure, which is pretty vast and extensive. So you can find me on the internet at Eddie Zane. This is a link to the slides, so feel free to screenshot this, take a picture, go back in the replay. This should live forever, hopefully. And it has a link to the GitHub repo with all the code that we're going to write today. So the first thing I want to talk about is React, which is a bit strange when you're talking about Kubernetes, but I think there's a lot of interesting things to discuss there. Then we're going to go into the Kubernetes API and talk through some of the terminology. Kubernetes has specific terms for different parts of its API and resources. Then we're going to take a look at client Go and some of its primitives. Then we're going to go through some examples and then throw it all together and actually build a controller. So if you have questions at any point, feel free to drop them in the chat and I will try to get to them when I can see them. So why am I going to talk about JavaScript? Well, most people have heard of React before or seen React. But when React came out back in maybe 2013, 14, it really changed the game with how front-end development was done. I was actually not a front-end developer at the time at all. I did a lot of Node back in the day, and knowing JavaScript and seeing React's patterns really brought me to learn more of like a full-stack thing to building websites and web apps. And what's really nice about React is it has this very declarative paradigm where we declare what our website should look like and it outputs a web page, right? And so the components for React are functional. For every input, you get the same output, right? And so the input is your state, maybe an API request, and the output of that is the web page that gets rendered. And this is pretty simple now when we think about it, but when this first came out, we moved from a very imperative model of using jQuery to move things around the DOM and change colors here and there. But with React, we wrote code once that all it was responsible for was showing the web page at any given point for any given state. And so here's a quick example of what a React component looks like. Again, this is just a JavaScript function. It takes in this initial count here. And you can see at the bottom here, that's where it's passed in. And so this is just a very simple button clicker counter. And we can load this up and we can see that it works as I click the count buttons, it goes up, resets and sets down, right? Cool. So again, that input is just, it's setting an initial state. Maybe this is coming from an API request and not hard coded here, right? But it is always just passing that down and showing the right thing. And these buttons will just kind of increment that count as it's pressed. Cool. One more example. So this is more of a traditional React component. This is like a full class. And you can see here, it's got a bunch of different functions and methods. The important one is that render. That's just going to render what the website should look like at any given time. It just returns a div with the state in here. And so if we look at this one, all this is a text box that we can type into, right? So it's like a two-way data binding thing. And that's not really that cool. But what's cool is how this works. And so this text box has a on-change listener. So it's listening for a change on this text box input. So when you're typing, you're not actually typing text into the box. JavaScript and React are capturing those key presses, and they are sending those events up to my function here that's setting the state to whatever the new keys that were typed into that text box is. Right? So it's, sure, you are typing in a text box, but you're not directly. And that's just kind of cool, like inversion. This really blew my mind when it came out because, again, we're dropping state in and it's just responding to events and it's making changes. And so as we talk more about Kubernetes and controllers, you're going to see this is pretty much the same pattern that Kubernetes operates on, where there is a central source of truth, a state, and then controllers and different operators will transition from a desired state to a current state. And I know that's far out there, but that's my pitch. So we're going to go see how this works. And so now I want to talk through just the Kubernetes API in general. So there are kind of four big terminologies we need to talk through. We're going to talk through a kind, resource, group, and version. So starting with a kind is a schema for an object, right? This is a mapping to a Go type particularly, right? So there is some Go struct out there that maps to a kind. Kinds always start with a capital letter, and it is usually a single object or a list of those objects. So you can see here, this is pod list, and deployment, right? These are all different kinds. And I'll explain more about this in a bit. A resource is what Kubernetes refers to as an endpoint, basically, right? It is an endpoint / path in the API. A resource is a lowercase and plural word, so it's pods with the plural. And so the kinds are the types of objects sent and accepted by these endpoints as JSON, right? So it is, the resource will accept the schema of type, pod, whatever, as a serialized Go struct and return the similar thing as JSON. And that's the fun thing about Kubernetes. Everyone always complains about YAML, but actually internally, it's all JSON. There is no real concept of YAML really inside of the Kubernetes API. It is serialized as JSON, written to the disk as JSON, and then converted to YAML at the client usually. All the web requests are actually done in JSON. So a group is a set of resources that are exposed together. It is versioned, and you can see a couple examples here. You've probably used them before. We have apps v1. That's where you'll find deployments. Networking.k8.io/v1. This is where the ingress objects will live. And then you can have your own custom API groups. So this is the one that we're going to use for our demo here. It's kubernetes.dev, which I'm super proud of. Shout out to Memo for thinking of that. And you might have noticed that when it comes to the built-in types that are the core types, so like pod, config map, those are under what we call the core API group, and sometimes they're just represented as an empty string internally. So it's a bit of a legacy thing there that we have to work with. Version, obviously, so unique versions to a group, v1 alpha 1, v1 alpha 2, etc., all the way up. And so one version of the object is stored and converted as requested at any given time. And so this is kind of an important piece where, sure, you may have a deployment v1 beta 1, deployment v1 alpha 1. There's only one version of a Kubernetes object stored at any given time. And so based on what version you request, a conversion is done to serve it in that particular version. So only one version that is actually stored, and we have these things called converters that they can be code generated to automatically give you the right version. There's a whole lot to do with backwards compatibility there. We're not going to get into it too much, but keep in mind. And so what we can do is we can take all those different things we just talked about and throw these together. And so these are the kind of the Go types that are represented that we work with. So group version, group resource, group kind, group version resource, and group version kind. And you'll see as we go through what this API input looks like, right? So this is just a regular Kubernetes API endpoint. And you can see that we have our groups here. So that's our apps group. There's our version that we talked about. There's the resource name, right? So this is the deployments resource. And that Nginx at the end there is just a particular named deployment. So this is getting a single deployment as opposed to listing all of them. So here's our group version, right? And so this is under the schema package that's built into Client Go, I think. It's either Client Go or API Machinery. But you can see here that this is what that resource gets represented as a Go type. Same thing with group resource. There's the group and the resource. And there's different reasons that we'd have one of these or not the other. We'll get into that in a bit. Here's the group version resource, right? So from these Go types, Kubernetes is able to figure out what we need most of the time, right? Like 99% of the time, this will be able to find out the group, the version, the resource, find the actual item we're looking for, and it's how it's represented as this Go struct. But sometimes we don't actually know all parts of that GVR or that GVK. And so we figure this out with a process that we call REST mapping inside of the API and inside of the clients. And so you can see here we have that resource, which is the group version resource, and then the group version kind. And then the scope is just if it's a cluster scoped object or a namespace scoped object. And so this really lets us map a kind to a resource. Right, so this is how we know when we have the request for something, how to look up what Go struct that we have to serialize and unserialize this into. And this is important because 90% of the code inside of the Kubernetes clients that you're going to work with are using this library that figures out from raw JSON string to a Go type, right? It's not an easy process. Use tons of reflection. There's this thing called a schema that we're going to look at, a scheme that we're going to look at in a second, and it's basically a registry. It just maps, string to Go type. And so hopefully some of this is not new. Maybe some of this is new, but I'm going to show you that it's not magic new. And so what we have here is, I don't think I have a cluster. Let me create a cluster real quick. If you haven't used kind before, use it. It's awesome. We couldn't live without it when working on Kubernetes upstream. It's amazing. Shout out to Ben. Thank you. So this will take a second. Cool. So now I have a Kubernetes cluster running locally. And so I can use that kubectl API resources command. And so this is this is how discovery works for the most part, right? So we have the mappings of my resource name, right? There's the version, there's the kind, knows the scope, right? And here's short names. You can ignore the short names column for now, right? And you see, if you just run this on any cluster, you will find out all of the API resources that are built in the cluster, right? This will work with CRDs and everything. We have another command that's very similar, and it's called API versions. And it basically shows you all those full groups in here, right, for those group versions that you can find. And so you see there's that V1 I mentioned. That's the core group. That's why it doesn't have the front name. And if you are building your own custom resources, don't use the KHIO or Kubernetes IO domains. Those are reserved for the internal project because it might break things if we ever overlap. Cool. So that's, again, that just works, that's magic, but how it works under the hood is when you do kubectl get, there's actually a raw flag you can pass, and this lets you make raw API requests to your Kubernetes cluster. So here I can say, give me back all those API endpoints, right? And I'll pipe this into JQ so you can see it better. Right, so this is pretty much that API resources command I just showed you as raw JSON, right? And it has its own kind, right? Because it needs to know what type to serialize this to. And the way that this works is when you're first talking to a cluster, it needs to do what's called discovery, right? So we have the REST mapping that we can map from Go type to these resources here. But the client is supposed to be dumb, right? The client needs to be as dumb as possible because a client version of, let's say you have a kubectl version 120, right? That should be able to talk to plus or minus one version of Kubernetes API, Generally, it works with many different versions too, but that's what we guarantee in our versioning SLA. And so the client can't know about all the possible types because there might be types that weren't existed when the client was created. And so when you first make a request, Kubernetes is going to go through and basically hit this endpoint, this API's endpoint, and it's going to grab all these versions and then make API requests to all of these and find out more information about them, right? So, okay, enough talk. Let me just show you what that is, right? So that's exactly what we were doing here before. So let's hit that apps v1 request. We'll say namespace default, and then we'll grab the deployments resource. And I typed something wrong, of course. Let's see. APIs, apps v1, oh, namespaces, plural, because namespaces are also a resource, right? Cool. So I don't have any deployments created, but let's say that we did. So let's say, what is this? Create image, create deployment image, nginx. We'll call this nginx. All right, so now if we hit that, we get back our deployment list. And we can walk through it just like before, right? So it's gonna have that list of items. And we'll get into these different fields here in a bit. Again, these all map to Go structs, and some of them are required. Like specifically items is required when you have a list, right? It always has to map to the array of all those different kinds. It needs to have the items key. Cool. Hopefully making sense so far, right? And none of this is magic, right? This is just doing what kube control will do under the hood and figuring that out. And if I do this, let's see, if I remove our cache directory, so this is how we can speed up that kind of discovery. We'll do discovery, and I think we TTL it for maybe an hour. But if I delete it, and then we do our first request, so if I say get deployments, and I'm going to give it like a verbosity level 6 here, and didn't do what I wanted. Let's do that again. Maybe I need 8. There we go. So you can see this is that discovery process where it's going and it's building out that cache. It's going to hit all these APIs one by one. So where's the first request? Right, it hits the API endpoint. So that's how you get the core APIs. And then if we go through, here's that actual API. So this is not the core ones. These are the different groups. It'll get back that list of groups. Here's that list of groups, right? Goes through one by one, making those requests, figuring out what's in there, what kinds they return. And this all gets written to disk. So we don't have to do it all the time, right? Because when you have a ton of different resources, a ton of different CRDs, it can take a long time to do all these round trips. The client can get rate limited, which we've had problems in the past before with how Crossplane does CRDs too. They've definitely pushed it to the limits of what was originally intended, and it's been great figuring out how do we make it better. So cool, makes sense, awesome. So that's the API request in a nutshell. And again, this REST mapping is done through taking those group version resources, mapping those to the kind structs. This is done inside of the Go code level, inside of client Go. I showed you how you can look at these API requests by hand and figure out what resources you have. And then just to tie things together, if we look at this example here, so we're gonna build a controller that can take a, if anyone has seen I'll just show you an example of it. So if we have, it's like crayon, cool. Right, so this is the DAL-E GPL models that are out there where you can give it a sentence and it will generate pictures using AI. It's pretty cool, right? So if I say a hamster wearing a pirate hat, so that'll take maybe like a minute to run. So we're going to take this concept and we're going to bake this into a Kubernetes resource and a custom controller. right? So the group that we're going to work with is that kubernetes.dev. We're just going to YOLO it and throw it into production with version v1. Our resource is going to be called pictures. That's going to be the API endpoint. And then picture is going to be the Go struct that we work with. Let that finish. And then I want to talk about client Go, but we'll give this a second to finish because I'm very curious what this is going to look like. Sometimes it takes a little longer. There we go. That's adorable. It does not do faces very well. If you couldn't tell, it's kind of the thing of nightmares sometimes, especially when you look up people's faces. But yeah, so that's the concept we're going to work with. But before we build our extra controller, we need to talk about the client Go primitives. And so there's a couple ones to talk through here. Work queue, informer, scheme, and runtime. You can see the first three are inside of that client Go package. This is your bread and butter when you're working with the Kubernetes API. And then runtime is in the API machinery package. This is kind of the underlying logic that client Go will use. So you can use these API machinery types and runtime in different places. So talking first about this work queue package, it's very simple and straightforward. It is a thread-safe work queue. And it has different implementations, different interfaces that you can use, including a rate limiting one. This is pretty much the most common that we're going to look at. So when your controller loop runs, we can say, hey, only retry 3 times if there's a failure. An informer, right? So there's a bit of a history behind informers. And so when we hit those API endpoints, Kubernetes implements the full CRUD endpoint, right? Like it's all a RESTful API. So we can get, post, put, delete, all that jazz. But there's also we have 2 other ones that we really use as well, which is a watch. So this is like a long-lived streaming connection. So you can make a watch to the pods endpoint and get streamed back events of pods created, updated, deleted, all that kind of jazz. And then there's a lister, which we can create a lister for pods, and it knows how to list all those pods out back by a store, right? There's some kind of cache store under that. So we take this watcher concept, we take this lister and put it together. We get what's called an informer. And this is important because these watch and list operations can put a lot of strain on the API server. And you don't want every single thing running multiple copies of all these watches and lists, especially if there's a shared controller running, right? For example, the Kube Controller Manager, which is the built-in Kubernetes controller for the built-in resources, it's got about 36 different APIs that it's listening and watching for. And so that's 36 open API requests at any time. And so obviously, as you add more to your cluster, if there's more using it, this can be really taxing. And so what we've done is we've taken this and wrapped it in a concept we called a shared informer, which is kind of like a singleton concept of the informer. It's backed by an in-memory cache, and it has this concept of a store, right? So when your API client needs to list all the deployments, for example, it will be able to pull from the informer's cache on disk, and the informer resyncs every 30 seconds or so. And so it definitely it saves a lot on the API. So that's the TLDR there, is it use the shared informers. It's not as important to get people to migrate to them as it used to be, because now most things are using shared informers by default. And then the scheme is what I mentioned before. This is that registry. This is how we can map a Go type to a GVK. So this is, we take Go type, initialize it, serialize it, and it gets mapped to that GVK as a string. And then there's the runtime object. And so this is the interface that every single Kubernetes resource must implement when it comes to the Go type. And so there's 2 very simple functions that are defined on here, getObjectKind and deepCopyObject. The first one is how we embed and encode type information into the object. So the object knows, what its kind is, what its group is, what its version is, all that jazz. And so that lets us work with these as, generic interface types, because until recently, Kubernetes didn't even have, Go didn't have generics. And so this was a way of engineering how we can figure out what Go struct we need and what Go struct we have from a generic type. And then this deep copy object method is important because the shared informer cache is read-only. And so when you get back a shared informer from when you get back a resource from the shared informer, you can't modify it at all. So we have a deep copy object that just does a deep clone of the Go struct and gives you a new one that you can write to and make changes to. Cool. So I've said CRDs and custom resources a few times. This is how you can extend Kubernetes. And so I'm going to pull up the CRD that we're going to be using. And so up until CRDs were introduced, I don't even remember what version it was, but you could back then create your own API server that you could register inside of Kubernetes. And this was pretty heavy-handed and kind of complicated to do. You had to roll your own API server with your own types. So to simplify this, we added the custom resource definitions in the API extensions group. And this lets you create a YAML type and a Kubernetes controller. The API extensions controller is running, and will kind of handle and create all these and do all the delegation for the API endpoint creation. So super magic, super easy. You don't have to get too deep into it to know that it works. So this is what our CRD is going to look like. It's always that full name of that resource in your group. Here's the group again that's specified, and then you can have those different versions. So this is going to be an array of versions. So there's that V1 version. It is served from the API. This tells the controller that it needs to create those endpoints, and it is stored inside of etcd. The API schema is just that open API schema. So you can see we're going to walk through. It's got that top level object, that spec property, that status property, and then some subfields. And so status is a unique value inside of Kubernetes that you may not have looked at before. When it comes to the spec, so right, you've created a resource, you know what a spec looks like. Spec is designed for user input, right? So the user is going to write that data into the spec, and the controller owns the status field, and it's going to write the status back into that. And so if you see here, our CRD, let me open an example of what this will look like. Right, so our spec is going to have a text field, which is here. And so that's going to be the sentence that we want the AI to generate. And then that status field is, again, that's for the controller to write to. And so inside of there, we're going to have a URL, right? So the API is going to give us a URL that we can look at that picture in. So that will be written to when that long 60-second API request is done. And then we have this field called observe generation. You may have seen this before. This is kind of a hack because the metadata field in a resource has a generation number, and it's just monotonic. It increments every time a change is made to this resource, right? So it starts at 1, goes all the way up. But the problem in the controller can happen where you don't know if you've seen this version of a resource before, right? Because sometimes changes might not need to be done, right? The controller does a resync every 30 seconds or so. And so we need to know if we've worked on this this item before. And so the way we do that is we write the last seen or the last observed generation number into the status. And then inside of our controller, we can check if our last observed doesn't match our current generation, we need to do work. So that's not really documented all that well inside of how the Kubernetes docs work, but it's pretty much an accepted pattern everywhere. And then the other bits in here, so sub-resources, right? So I showed you how we can have resources inside the URL. Sub-resources are that after that /deployment /nginx, we can have a status field. And this kind of just turns on the status field for the API inside the controller. And then we have these additional printer columns. These are when you do kube control get resource. it knows what to show you in those fields. And the way that actually works under the hood is pretty cool. There is let me see if I can show it to you here. So if I say kget deployments -v8, we'll see that the accept header for that request that is made, right? So there's the API endpoint that we hit, pretty much what we'd expect, and I showed you before. But the accept header is going to have this as table field in here. And so this is the cool part that tells the Kubernetes API server to send this back in this table format. And so this has all of the information. Remember, I mentioned that the clients need to be as dumb as possible, and they need to go off discovery information from the server. And so this body is actually what kubectl will read, and it knows what columns to print out when we do get deployments, right? So pretty cool how that works. And so that's what these printer columns are. This just says that, hey, I want a field name text, which is that input box, and it should follow this JSON path, right? Makes sense. Same thing with URL. It's going to follow the status to grab that URL. Scope is namespaced, and then we have these names in here that we have to add. So plural picture, singular picture, and then kind picture, right? That capital P. Cool. Hopefully that's making sense. And so now that we've explained CRDs, we can actually jump into what controllers are. So the basic Kubernetes controller, and sure, we have all this boilerplate and all these different libraries and functions and patterns to do things, but at the root of it, you could do this in Bash if you wanted to. I think Justin Garrison Rothgar on GitHub or Twitter has done a Kubernetes controller in Bash, or someone else has, so I'm sorry if I don't remember who you are. But this is the root of it, right? So in a infinite loop, get the desired state from the spec, get the current state from the status, and then make change, right? So do a diff, figure out what we need to do to transition our object from what's desired to how it currently is. And that gets written back into the state. So very simple, very straightforward concept. So taking a look at some controllers you may have used before, Cert Manager, probably the most common CRD and controller combo out there. This lets you create TLS certs based on different issuer bits. So you can, issue them from AWS, GCP, Let's Encrypt, Cloudflare. Here's what an ingress looks like, right? So this is that networking, regular ingress, not a CRD, but it has that annotation. And so there's different types and patterns of controllers. So this controller actually watches for ingress resources that are annotated with that cluster issuer item. And then it goes through to the bottom there, that TLS key and that hosts list. It will go and it will use whatever Let's Encrypt staging issuer that is, and it will make sure that there are TLS certs created and registered for those domains, right? So this is a controller. It has its own resources, sure, but a lot of the work done here is actually operating on watching other resources, right? So your controller can control and work with resources that it doesn't own. I mentioned Crossplane before. Crossplane is kind of like Terraform for Kubernetes, where we can have, this is a GCP Cloud SQL instance. And so you can install this, this resource into your Kubernetes cluster, and the Crossplane controller knows about these different providers. And so I can create a Cloud SQL instance inside of GCP by using a Kubernetes CRD. So really cool. They have different CRDs for different bits, right? And so this is managing external infrastructure inside of a Kubernetes cluster, right? So taking that Terraform state and moving it from a state file or whatever you're using for your Terraform state into your Kubernetes cluster. So pros and cons, and there's different reasons why you'd want to do this, but if you want to put everything inside of a cluster, you absolutely can. And then my favorite example of a CRD, so this is Cluster API, which is a play on Cluster API, which is another bit of Kubernetes controller inception, where Cluster API is designed to create Kubernetes clusters from a Kubernetes cluster. Well, Cluster API can order you Domino's Pizza from a Kubernetes cluster. So you can see here, this actually works. There's a demo in the repo, and it runs through. This uses a API client for Domino's that the author built as well. And you fill out the CRD. You have this payment secret that you set up ahead of time that maps the credit card info. And the controller will go and make you a Domino's Pizza API request, and you will have Domino's Pizza delivered in 30 minutes or whatever their SLA is there. So really cool. So just some ideas of different controllers and how they can manage different resources. So this is the important caveat. So we're about to dive into a ton of dense code. There's a lot of boilerplate here. There are easier ways to build controllers. The point of this talk and what I was going after originally was to show you the primitives so you know what's going on under the hood, right? So when you see a panic for a shared informer, you know what it is. There are other bits out there like Cube Builder, controller runtime. All of these make building Kubernetes controllers much easier, and you should definitely take a look at them. But if you want to understand the primitives, that's what the point of this talk is for. So don't get scared away by all the dense code. That's my warning here. And so this is what a Kubernetes controller looks like in a diagram format. And so if you start up here at the top left, top right with me, so we have that Kubernetes API that I mentioned, the lister and watcher. That's called a reflector, but you'll probably never see that again. So the lister and watcher is going to watch that Kubernetes API endpoint. As new resources are created, they're going to pop that into the work queue, right? I mean, this is its own queue. The work queue we'll get to in a minute, but the shared informer, that whole reflector bit that has its own queue, it's going to write any new changes that come into this queue. And we come into the informer is going to pop out of that queue, grab the object, write that to the indexer. Remember I mentioned that you don't make direct API requests. You go through the indexer, and it's going to serve you from its cache, its store, right? So all of that, those first 4 or 5 steps are magically hidden for you. You don't really have to think about them. And then when it comes to the informer, we can register callback functions to it, which is really nice. So we'll take a look at that in a second, but we can register an add func, an update func, and a delete func. And these are called when new objects are created, updated, and deleted. And it's inside of our Go code. Excuse me. And then we can come through, so this is our controller handling those events. It's going to enqueue on our actual work queue that we're using, right? So it's going to take the namespace and the name of the resource, or there's like a key function, and it's going to write that into the queue. The controller is going to pop those off in that infinite for loop, handle the object, do whatever it needs, right back into the indexer right back to the API. Cool. So very simple diagram when you know what's happening. Again, those first like 5 things you don't do yourself, the shared informer does for you, but this is what a controller looks like in a diagram. So now we can dive into code. So hopefully I remember all the things to write here, because it's been a whole week. So let's see. I have this repo that you can check out on my GitHub. It's just github.com/EddieZane. It's called that conference cage controller. It's also linked in the slide deck at the end. So if we open up the main function here, so I got a ton of boilerplate in here. A lot of it's really dry, and a lot of this is copy paste between controllers. So I know I said from scratch. This is as scratch as we're going to get, because it is very dry to watch all of this be written. Before we take a look at that, I'm going to show you what the whole type situation looks like. So you saw what our CRD was. And then what we need to do is we need to take that CRD and represent that as a Go type, right? This is our actual kind that we're working with. And so there's folder convention for this, and there's scripts that do code generation. A lot of Kubernetes and a lot of Go in general is just code generated, because there weren't generics up until recently. A lot of what we do is we write code that generates other code. So there will be a generator that's going to read this and print out everything we need and create all the other files. So this is our picture struct, right? This is that spec field I mentioned. This is that status field I mentioned. These are these are embedded structs. And so if you're not familiar with how Go does this, you can embed a type into another type, and it kind of just inherits all the other subtypes in there. Right, so we have a type meta. This is what's holding that kind of that API version. So these fields just get added to the type that we have here. And then we have the object meta. And this is what you're familiar with when you have that, meta field inside of your Kubernetes YAML file that you're writing. So this is the actual type that maps to it under the hood. Right, so we have that name field, generate name, namespace, right? All these jazz. You've probably seen all these fields before. I mentioned the generation field. Resource version is similar to generation. Creation timestamp, right? So bunch of stuff in here, labels. So this is where that metadata field comes from. And then, so these are subtypes here as well. So we have that picture spec. It's got that text field, and then our status, right? It has a URL and our observed generation. And for the Go folks out there, this probably doesn't need explaining, but this bit is some metadata text things, encoding strings. This is an encoding string where the JSON marshaller and unmarshaller will know how to go from a JSON name to a Go name here, right? And because the way Go does public and private, capital words are public, lowercase words are private. And so this is just how we can map the JSON field, which is usually a lowercase key name, to a type here. And then this emit empty declarative declaration thing just says, hey, just don't shit the bed if this field is missing in the JSON. Right, same thing with here, that's all this is. So this maps that spec API JSON to this Go type, cool. And then of course we have to have the list structure I talked about, right? So it needs to be plural. And so there's that items field that we mentioned before, right? So this is all just, you can copy paste these from the sample controller and other places. Don't get too caught up on this. Same thing with the structure here. And you may have noticed these comment fields. So this is how that magic code generation works. So we have this, the folder layout is, we have our package field, our APIs field, our resource name, and then those versions. And then the group that it belongs to is usually in here as well, right, as a constant. And then this file is super dense and confusing. This is where that scheme mapping comes, where we go from Go type to group resource. And so you can see these don't actually exist yet because I haven't run the code generation. This is copy paste. The Programming Kubernetes book, which I have somewhere as well. There it is. This is a great book, especially if you're going to get into writing controllers. Great authors, great people. I've worked with both of them before. Pick this book up if you really want to know the ins and outs of how this works, but this is a copy paste boilerplate file, right? This exposes some things for code generation to use because the scheme doesn't know those API types at the start, and we need to be able to compile, ship our code, do all these things without the generated code existing at some point, or it knowing about it really. So that's really what this is for. And then here's some more comment fields. So this kind of opts in the file and the package here to code generation. So there's our group name, and this just says, hey, you can code gen for that deep copy method for the whole package. And then you notice these. This gen client one is pretty magic and cool. Having this inside here will just generate us an API client, right? Full API client, all those REST and CRUD operations. Don't have to write a lick of it. It just knows how to do it because it's all convention. So cool, all right, let's generate that code. So I'm gonna run this update codegen script, which I'll give you a peek at. But again, this is all copy paste. All right, so now you can see it's generated this whole generated folder and this ZZ generated deep copy file. And so that update codegen script, this is all really confusing bash and convention, but again, it's copy paste from one resource to another. This calls the generate group script. This is directly copied out of the Go codegen package for Kubernetes. And it just knows how to call all the different code generators, right? So this deep copy gen, client gen, lister gen, informer gen, which all generate what they sound like. And then it takes in our path that we want that code at, right? So that package generated folder I showed you, it tells it where to find our API types and groups, which is what I showed you before. Here's the one that it wants us to actually generate. So I'm saying, hey, generate pictures v1. And then this just kind of makes it work with Go modules. So like I said, kind of dense, kind of confusing, just copy paste it all. And then that's the actual codegen package. This is just a Go way to make sure that the dependency doesn't get lost and stays in our dependency tree. Cool. And so now we have that deep copy generated function. Again, warns you that this is code generated. Do not edit it. And there is our deep copy functions. So this will just work. Very cool. Same thing if we look at the register function now, that error is gone because this type exists. We can see it. It's been generated. Cool. And then here's our client that was generated. So this has the full REST client for our type. It's got our registration bits and how it adds it to the scheme. Bunch of other CRUD methods in here, right? So definitely go through the sample controller. Definitely have a look at the code here. Again, it's all codegen in just boilerplate. So now that we have our code generated, we can actually start working on our controller. So our controller struct, I'm just going to have a high-level struct here that's going to hold all of those things we talked about. So the queue, the informer, and then our API client, so our client set. And then this is the API client that, shout out to Billy, he helped me write this for making API requests to that AI gen website. Very cool. And we have a backup here in case I get banned and blocked. And then we have this new controller constructor that just takes those in and then returns a controller, right? Cool. Okay. So the first thing I'm going to do inside of our main function here is I'm going to initialize klog. This is the logger that we use, and I'm just going to add a bunch of logging so I don't mess up all this typing. The next thing we need to do is there's different ways for our controller to get credentials to talk to our API server. You may have seen different ways to do this before. We can check for environment variables. You can do the --kube config flag. If you're in a cluster, it looks for the /var run Kubernetes. There's a well-known path to your service token.json or whatever the file is called. We could hard-code all this, or we could just use this generic CLI options package. This knows all of those different loading rules, and we'll figure out the right kube config for us to use. So big fan of the loading rules here. I'm going to tell it to persist to config. Config flags. So this will give us config flags that we can use. From those config flags, I can get the to REST client. So this will give me a REST client that I can actually work with, right? So this is what's required for the API client. It goes from those config flags to figuring out where our kube config lives, and then turns that into a struct with API endpoint, all that other authentication jazz. And so what does this give? This gives config and an error. So we'll just panic if there's an error. Handle your errors better. And so now we have our config and we can create our actual client. So I'm going to say client set new for configure die, give it our config. This will give us our client. And this client set is just the one we saw from CodeGen before. All right, so here is that Kubernetes generated one. Cool. So now we have our client. We got to create a couple other things. So I'm going to create our shared informer factory. This is how we can create those shared informers. So let's say, where does this live? Informers.new shared informer factory. This is, again, from our code gen. So I'm going to give this the client that I just created. And then this is going to be the default resync period. So we'll say, hey, you should resync every 30 seconds. And this will give me a factory. Cool. So we have our factory. And from our factory, we can actually create our informer. So I'm going to say informer equals factory dot Kubernetes v1 pictures informer, right? Again, this is all code gen, so a lot of boilerplate, but magic. So now we have an informer, and then we just need our queue. So let's say queue, work queue, dot new rate limiting queue, and that needs to take in a rate limiting strategy, so we'll just give it the default one. Again, all this is extensible and there's reasons to do everything. So now we have our rate limiting work queue. Awesome. Finally, we can create our instance of our controller. And so I'm going to say new controller, give it the queue, give it the informer, and give it the client. Boom. So I mentioned those callback functions earlier, and so this is where we can register those callback functions with the informer. So I'm going to say controller, informer, and then add event handlers. This takes in the cache. I think it's this one, resource event handler funcs, add func, update func, and then delete func. Cool. So these get called whenever, like I said, something gets added, updated, or deleted. And so when a new item gets added to the informer, right? So it's watching, it's doing that FIFO queue, writing it into the indexer, all that jazz. It's going to call this and pass us the new object. And so all we care about now is actually the key. So I'm going to say key equals meta namespace index func. I think that's it. It's one of these. This one. Meta namespace key func. And so this knows how to take a runtime object and give us back a unique cache key. Right? It splits on the name, the namespace, the resource, all that jazz. And I'm just going to ignore the error because I'm a bad developer. And so now we have our key. I'm going to add to queue. So let's just log that out that we're going to do it. So we'll say info, adding to queue, give it the key. And then we have to take our controller, our queue, and then add the key. Cool. I think that's it for the add function. Pretty straightforward. Update's a bit different. So update gives us the old object and the new object. And so I'm going to typecast these at first, or type assert so we know what they are, because we do know what they are. So I'm going to say this is a picture v1 picture. So we'll call this old. And then we'll call this new. And then we'll grab the key out of the new one as well. And so here's where we check if there's actual work that needs to be done. So we can say if old object dot resource version equals new dot resource version. Right, so if this is the same resource, maybe this was just a periodic resync, we're not going to do anything. So we'll just klog info periodic resync. Right, so this is that 30-second timer. It's going to do this every 30 seconds. Cool. And so if it's not a periodic resync, we need to enqueue this for work to be done. So let's log that too. Need to queue for update. Cool. And then queue add key. I think that's it. And here we're just gonna say an item was deleted. There might be reasons that you want to do cleanup and finalize. Our controller doesn't need it, so I'm not gonna add anything here other than a delete log. And then log info s, item deleted. Cool. I know this is pretty dense, just bear with me. We're gonna get to the good stuff soon. Again, this is all boilerplate. So we haven't gotten to our business logic yet. So then we need to start our actual controller. So I'm gonna say info s starting controller. We'll say stopping here. And now we can say, I need a context to give this. So we have this signal handler ones that will do the magic for us. This sets up signals for control C, kill, all that jazz, and wraps it into a nice context for us to use. Now we can finally tell our controller to run and then give it that contexts channel. Cool. So inside of our run function, we need to do a few things. We need to register some panic handlers. So util runtime dot, there's a panic something, oh, handle crash. We'll wrap that in a defer. Does that need a defer? I think so. And then what else do we need to do? We need to start our informer. Our informer actually hasn't started yet, so we need to fire it up. And so we can do that with C informer dot start run. It's run. And we will give it our stop channel. This is a blocking run, so I'm gonna start that in a go routine. And then we need to wait for that cache to sync. That could take some time. So thankfully we have a wait for cache to sync function that makes that real easy to do. And this takes in the informer has synced function. Cool. So this will return true or false. So we'll say if the sync doesn't complete, I don't know, let's just panic. Can't sync. That shouldn't happen, hopefully. Now we need to start workers, right? And so we can process these requests in different Go routines. So I'm just gonna start one. You might wanna run multiple based on CPU cores or however many are allocated to the pod. I'm just gonna say c.run worker. Think that will work. And then we need to wait on that stop channel to finish. So here's where our worker is running. And so this one's simple. We're gonna say klog starting worker. And then here's that infinite loop that we looked at before. So this will say for controller process next item. And then this is just, you know, loop forever. And then, again, this is more of a convention than anything. Our process next item function will return true or false. True if it's still, you know, ready to process, and false if it was told to shut down or something went bad. And so I think the first thing we do here is we pop our item. Let's say get. And so if it's time to shut down, our queue will tell us if we need to shut down. I think we can just return false here. So our item is the key name from the queue. So I'm just gonna call that key. And then I'm gonna wrap this in a a function so we can run in a Go routine. This is going to kick off some API requests and some other things that need to happen, or actually I think I'm getting ahead of myself. This needs to process the item. Yeah, that's what it needs to do. So we need to take in a key string here. I think I want to do that. This is going to take that key and assert that it is a string. Cool. So the first thing we will do is I'm going to tell it to defer the queue of done with that item. And so this is just to make sure that we always finish with the item from the queue, so it can be re-queued if something happened or something, you know, there's a rate limit. So that's why we wrap this in a go func, so we can defer it here. And then we need to call process item with that key. This will return an error. So if error is nil, we can just say done with work. Give it the key. I think that's it for that one. Else if, so this is where we want to know if our item has been rate limited or not. So we can do that with c.q.num requests for the key. So here we can say if it's over 2, right, maybe we want to retry twice. Or now let's say, yeah, we'll say if it's over 2, we're going to bail out. So we're done trying. So we'll say klog info s done retrying for retrying key. I'm going to say forget this item. So forget will clear the rate limiting for this item. So we'll make sure to do that. And then we need to log this error. So let's say there's a util runtime thing here for handle error. You can register different error handlers if you want like Sentry or something to run off. This will just log the error by default. I think that's it. Otherwise, if we're not above the queue, we're just gonna re-queue this thing. So we'll say will retry. And then we need to queue.add rate limited for that key. I think this is it. I may have missed something. It'll probably break if I did. Okay, so this is where we actually finally get to do the business logic, right? So everything else is convention and boilerplate until this point. So we have our key, and we need to actually get the picture resource, the picture kind type, from that key name. And so we can do that from the informer indexer dot get, give it the key name. That gives me back the item if it exists and an error. So we will say if error does not equal nil, return error. If the item does not exist, right? So maybe this got deleted and the item's still left in the queue. We're just going to return nil, so it should just finish with it. So if we get to this point, we know that we actually have a picture. So we'll say picture equals item, and we'll assert that to, what is it? Pictures v1 picture. And this is going to be a pointer. Let's clear that error out. So now we actually have a picture. And so what do we want to do? Well, we want to check if this is finally our business logic. So we can say if the status URL field is empty, or the picture generation does not equal the picture status observe generation, right? So, hey, something changed, or we haven't seen this version of this object before, we should do a resync anyway. Right, maybe we changed the text in the field. And so now we can make our API request. So that's this guy, get image, give it the picture spec text. What is this? This is a URL that we get back here and an error. So if the error is not nil, we want to return it. And so now we need to actually update our picture. So I'm just gonna say picture, and we need to do that deep copy because we can't write to the read-only version from the indexer. And so now we can say p.status.url equals the URL, and then p.status observe generation equals p.generation, right? Just like before. Cool. And now we can actually use our client to write that back to the API server. So we'll say c.client.kubernetes pictures. This wants the namespace of the picture. This is pretty standard if you've used client Go before, or a client set. And so by doing update status, we can now give it a context. So context.background, give it that picture that we updated, and then these update options, which we could do like filters in here or labels if we wanted to. I don't care about this return. I just care about the error. So we'll say if error is not nil, return error. I think that might be it. I'm definitely forgetting something. I'm forgetting a wait somewhere. Where do we use wait? Ah, we use wait. Wait for wait func. You know what? I don't remember. We're gonna find out in a second when it doesn't work. Let me comment that out. Let's see what happens. So I'm going to apply that CRD to our cluster. And then let's set up, I don't know, we'll say watch cube control, watch cube control get pictures, no pictures yet. And then we will go run. Oh shoot, I need to export something. What do I need to export? I need to export a bucket name. Oh, I have to do a few things. I gotta log into GCP real quick. Give me a second. Looking at secrets you can't see. So, gcloud auth login. Allow. Plug in my security key. Okay. All right, and then I need to gcloud auth application default login. Hopefully that was it. So I'm just getting some credentials right now from GCP that I can use. Normally you'd want to do this with like identity providers. But we're doing it this way. So let's see. Now we can export bucket name equals, let me get the right bucket name. So my little Crayon API client will do some magic and upload a picture to GCS so we can have a URL for it. I just have to grab the bucket name. Okay. Chainguard pub. Cool. So now I think we can run it and figure out what I did wrong. So this is going to compile and run it. And again, if you build this into a container, you do your auth a bit differently. My auth is just using my local credentials here. So my local kube config and my local GCP creds. So now the moment of truth is we're going to apply this picture. Oh, I did something wrong. What did I do wrong? Let's find out. All right. Adding to queue. Couldn't create key for object. Object has no meta. Object does not implement the object interfaces. Okay. Let's see. What did I do? Well, meta namespace keyfunc. Check this error. Until runtime, handle error. Try it again. Ooh, come on. Could not create key for object. 114. I did something wrong. Get that. Indexer get. Couldn't create key for object. You know what? We're just gonna check out the working version and we'll see what happened. That's what I get for not rehearsing. Let's see, what do we do? We enqueue that, which we did. Meta namespace keyfunc. Pretty sure that's what we were doing. And then, where is that error coming from? So, oh, we popped the queue here. That's what I did wrong. Cool. No, I think I popped it there. So pop the key, give it the key, process item with the key. Pictures. Go get by key. I definitely did not use get by key. That's all it is. Do our code gen again. Nothing like figuring it out live. Ah, right here. Okay. So this is get by key. There we go. So hopefully now that just works. Still don't know where the weight was from. Okay, it added to our queue. Don't actually know if it's doing any work. Did I miss a log? Let's see. So there's our custom table. I mean our additional printer column, right? So it filled it in there. I think I definitely missed a bunch of logging lines. But I think we just wait for this to work and Hopefully we get a creepy looking picture of a little girl wearing a traffic cone on her head. Anybody have questions that I can answer while this is running? Thanks for sticking with me. I know this is kind of dry. Oh, it worked. Hell yeah. So let's look at that picture. And this is the reward we deserve. Oh my God. It is the thing of nightmares. And so we can see, let's add another one. So I'm gonna add a red car flying in space, and you know what, let's not make this a creepy little girl. What should we make this? We should say a kraken eating a pirate hamster. And we'll see that we should get some updates happening. If you look over here, you can actually see, right? So here's the logs that we had. So there's the periodic resync. That's at every 30 seconds where the resource version is the same. So it's not actually doing anything. And then this was when we made the change to the girl just now. So it changed. We had to do an update. Same thing, adding to queue, done with work. I'm glad it worked other than missing that one function, but you don't get to see the error handling and the retrying, but that's okay. So let's look at a red car flying in space. That's definitely a red car in space, very cool. And then let's see what this came up with. I think it finished. That is a kraken. And that kind of looks like a hamster pirate. Not bad. Good job, AI. So, cool. And so, I think back to the slides here. So cool. So there's a couple things we didn't do and I didn't talk about. Kubernetes has a concept of events for different resources. And so you can, if you ever look at like describe in here, so let's say describe deployment, right? You'll see these events in here. This is part of CRDs and you can extend this as well inside of your controller. You should definitely do this and it logs status, right? So I could have created an event that's like, I'm gonna make an API request now. I actually successfully did something, right? So that's what events are. So you should definitely have events inside of your resources. Converters are, I mentioned earlier that there's only one version of a resource ever stored, and it is converted to serve the requested version. And so we can code gen those converters. So we don't have to write all of them by hand. It knows how to, you know, add the new fields here, figure it out. And so yeah, so converters are definitely something that you need to have if you're working with multiple versions of a resource. Owner references as well. You may have seen this before. This is just how we can say that our controller owns this resource. There's a lot you can do, especially when you're managing other resources that you don't own. You should be checking for owner references. Same thing with managed fields. You may have seen that before. We could set managed fields in our resource to know what controller is managing what fields where. And then obviously the deletion finalizer piece I mentioned. When we delete our resource, it just goes away. So delete picture, right? There's our item deleted. You know, we may have some kind of cleanup that we want to do, some kind of other finalizer bits in there. So you should absolutely figure out your cleanup logic, but thankfully we didn't need to for our API. Maybe our finalizer, we could have actually removed that item from GCS. That would have been pretty nice. Some additional resources for you to look at. There's a link to this repo with all the code that we worked through and some other fun examples that I didn't actually get to talk about. The contributor developer SIG API convention docs here is a really awesome resource. It's the source of truth for all these terms and different bits in here. Definitely give that one a read. I mentioned this book before. Programming Kubernetes, highly recommend, really great read. Has basically all of this and more and way better explanation than I can do. And then one of my co-chairs, Mache, he gave this talk at a KubeCon for writing kube controllers. And it's very similar to this, goes through that diagram and other bits, and give that a watch. So that is all I had for the talk. I'd love to answer any questions folks have about what we talked through today, about Kubernetes controllers, about getting involved upstream and working on Kubernetes. If you joined us late, I help maintain the Kubernetes project. I chair the special interest group that works on the CLI tooling mostly. And so kube control, all of that jazz is in my wheelhouse and where I spend time. Yep, happy to answer any questions. Otherwise, I'm gonna probably log off. I can show those examples too real quick, so let's clean that up. So these are neat because you don't always have a client set that knows about the types inside of to work with, right? So maybe you have, you know the API resource exists, but you don't have the kind and you don't have the Go struct for it. So you don't have an API client that can be generated. Well, there's another client built into Client Go called the dynamic client. And so I'm showing the wrong thing. The dynamic client, right? And so just like before where we got our REST flags, we can grab the dynamic package out of Client Go. We can create a dynamic client, and then to hit the API, all we actually need to do there is use client and then grab the resource. So this takes in that group version resource that we looked at in the slides earlier. So I know that my resource is in the Kubernetes group, it's version v1, and its resource name is pictures. And then I can list them. Really cool, right? And so here I do have so maybe I do have the struct, or I make my own local struct. I don't have to have the client set, or I can serialize into this. I can work with this as an actual runtime object, right? So here's doing the default unstructured converter. Unstructured is the other magic piece we didn't get to, where if we get a resource back inside of Go from a dynamic client, it doesn't know what type it is, right? So it puts it into a string map interface. And that's really what an unstructured object is, right? Here's unstructured. It is a map string interface. Super straightforward. And so here's where I can tell it to convert. This is what that scheme will do for us under the hood, really. It knows how to go from that unstructured, that raw JSON, to a actual type, right? And if I run this, examples, dynamic, right? This should just list out all the pictures that we have in our API. Cool. All right. No one has any questions. I'm gonna sign off. Thank you all for hanging out and joining. This recording I'll get on YouTube. That was the whole point of doing this live, so I could have it on YouTube. And yeah, I will see y'all later. Bye-bye.